Critical factors for resilience in construction project-based organizations include having robust governance, strong financial health, and effective leadership. Other key factors are flexibility in operations and resource allocation, a focus on learning and innovation, and fostering strong collaboration and communication among stakeholders. A shared vision and the ability to adapt to change are also crucial. Construction projects are often organized as project-based entities, meaning each project operates with its own unique structure, objectives, and team. Despite the vital role these organizations play in shaping infrastructure and the built environment, there has been limited research into how they develop and maintain resilience. Organizational resilience refers to the ability to anticipate, prepare for, respond to, and adapt to unexpected disruptions or challenges. Studying resilience in construction projects is particularly important because these projects frequently encounter uncertainties ranging from supply chain issues to environmental risks. Understanding resilience can help project teams navigate complexities more effectively, ensuring successful outcomes even in the face of adversity. This focus not only benefits individual projects, but also contributes to the broader stability and adaptability of the construction industry as a whole. Governance and leadership. Strong governance. Establish clear regulatory and governance structures as believe their systems are strong, but find they are not when a major event occurs. Effective leadership. Leaders must align people's values, foster a shared vision, and influence their teams to believe in what they are doing. Project governance. Formal and informal governance mechanisms, including contractual arrangements and the management of project culture, are vital for resilience. Financial and operational factors. Financial health. Maintain strong financial health to withstand economic volatility, ensure viability, and fund resilience investments. Flexibility. Be able to reallocate staff, adjust working hours, and reorganize operations to respond to disruptions. Business continuity. Develop and maintain business continuity plans to ensure operations can continue during a crisis. Human and collaborative elements. Human resources. Minimize turnover and absenteeism and invest in people as they are essential for project delivery. Collaboration. Build strong network collaborations across partners and establish effective cross-organizational cooperation mechanisms to coordinate strategies. Communication. Ensure robust crisis management and communication capabilities are in place. Adaptability and innovation. Organizational learning. Foster a culture of continuous improvement and learning from past experiences. Innovation and technology. Adopt technological advancements and innovative project delivery methods to stay competitive and adapt to industry challenges. Anticipation. Develop the capacity to monitor what is happening, learn from it, and anticipate what might happen next. Organizational resilience in complex systems refers to the capacity of an organization to withstand unexpected challenges, adapt to changing circumstances, and recover efficiently from disruptions. In the context of construction projects, these traits are particularly vital due to the dynamic and often unpredictable nature of the industry. Resilient organizations demonstrate flexibility, effective communication, and a proactive approach to problem solving. They are able to absorb pressure from unforeseen events, such as delays or resource shortages, and respond constructively to minimize negative impacts. A proposed definition of organizational resilience for construction projects emphasizes not only the ability to endure stress, but also to adapt positively and recover swiftly. This ensures that projects can continue moving forward, even when faced with significant obstacles. Ultimately, fostering resilience within construction teams leads to improved project outcomes and greater long-term success. In systems thinking, when applied to project management, various strategies like system redundancy, process decentralization, and alternative technologies that contribute to increasing construction project resilience to risk factors as systems are kept in perspective. Selecting optimal strategies requires developing effective quantitative methods to assess their effectiveness and enhance project resilience as a system. A method of simulating time and cost propagation across a project structure, treated as a system and modeled using meta-network theory as a result of risk factor materialization. In this respect, this study fills an important gap in modeling risk factor materialization consequences in projects as systems. 3 additional strategies of enhancing project resilience to said risk factors are proposed, along with an approach to verifying their effectiveness using the Monte Carlo simulation model and taboo search meta-heuristics. The approach was validated on a real-world case construction project. Despite the approach being developed with construction projects in mind, the universality of meta-network theory means that it can have a wide range of applications beyond this sector. Difficulties in keeping planned project completion deadlines and budgets are often linked to high risk levels. The awareness of planners of the inability to procure precise information about essential project parameters, task completion times and cost, and the conditions of project performance means that traditional construction project planning approaches are still mostly reactive and non-integrated modes of action. Environmental uncertainty, social public events, and increasing challenges has raised the urgency for the need to improve organizational resilience of construction projects, which is of great significance to the success and governance of construction projects. This capacity is built on factors that help a project resist initial disruptions. Slack resources. Maintaining a margin of extra resources like materials, equipment, and cash reserves that can be deployed during a crisis. Redundancy. Creating backup systems and alternative pathways so a project can continue functioning if one part fails. This can apply to supply chains, personnel, and equipment. Risk analysis. Conducting comprehensive, proactive risk assessments to anticipate potential hazards and vulnerabilities. Strategic planning. Developing flexible and adjustable plans that can account for different scenarios, rather than relying on a rigid blueprint. Insurance awareness. Ensuring the project has necessary insurance coverage and that all parties understand the policy details, such as coverage, exclusions, and compensation procedures. Absorptive capacity. This capacity is built on factors that help a project resist initial disruptions. Slack resources. Maintaining a margin of extra resources like materials, equipment, and cash reserves that can be deployed during a crisis. Redundancy. Creating backup systems and alternative pathways so a project can continue functioning if one part fails. This can apply to supply chains, personnel, and equipment. Risk analysis. Conducting comprehensive, proactive risk assessments to anticipate potential hazards and vulnerabilities. Strategic planning. Developing flexible and adjustable plans that can account for different scenarios, rather than relying on a rigid blueprint. Insurance awareness. Ensuring the project has necessary insurance coverage and that all parties understand the policy details, such as coverage, exclusions, and compensation procedures. Adaptive capacity. Adaptive capacity is based on a project's ability to react and reorganize in the face of unexpected disruptions. Leadership and organization. Possessing strong, transparent leadership that can make quick, reliable decisions during a crisis. This also involves creating a flexible organizational structure with clear authorization mechanisms. Communication and coordination. Fostering transparent and effective communication among all stakeholders, including contractors, suppliers, and investors. Information and knowledge. Collecting and sharing information efficiently across the organization to improve situational awareness. Digital integration, such as building information modeling, BIM, and Internet of Things, IoT devices, is critical for real-time monitoring. Innovation. having the ability to apply new methods and ideas to solve emerging problems that the original plan did not anticipate. Cooperation, establishing stable, cooperative relationships and alliances with suppliers and partners which can provide mutual support during a disruption. Restorative capacity. This capacity involves a project's ability to recover from a disturbance and return to or adapt toward its intended function. Loss assessment. Thoroughly investigating and quantifying the range and extent of damage following an event. Replanning. Developing new or adjusted plans that fit the post-disruption situation, including prioritizing recovery actions. External resources. Having access to external resources and assistance that can help address complex recovery challenges. Acceleration capacity. Being able to accelerate production to offset schedule delays and get the project back on track. Broader considerations. In addition to the core capacities, other factors shape the overall resilience of a construction project. Culture of safety. Beyond regulations, a positive safety culture is a major factor in resilience. It fosters good decision-making, promotes continuous training, and builds awareness among employees to prevent accidents and protect well-being. Resilient supply chains. Creating secure and flexible supply chains by diversifying suppliers and leveraging local partnerships. This prevents dependence on a single source and minimizes disruptions during widespread events like a pandemic. Flexible contracts. Using contracts with clauses that allow for flexibility. This enables project teams to adapt to changes in scope, timeline, and cost without triggering major disputes. Environmental and regulatory compliance. Integrating environmental and regulatory compliance into planning from the outset, rather than viewing it as a hurdle. This helps projects adapt to policy shifts and new regulations.